All right, in this video, we're using the quadratic formula to solve quadratic equations. Let's start with example A then. All right, first thing you need to do is write it as a traditional quadratic. So we're going to bring everything to one side, leaving 0 on the other side. So for example, I could subtract 3x squared from both sides and add 1 to both sides in order to write this as a quadratic equal to 0. Because these items would cancel out, it'd have 0 on the left, and then 5x squared minus 3x squared gives you 2x squared. Then you'd have minus 3x and then negative 4 when you combine positive 1 and negative 5. All right, from here we can see that the a term for the problem is 2, the b term for the problem is negative 3, and the coefficient for the c term is just negative 4. So there it is. There are your a, b, and c coefficients. We need these coefficients to be able to plug them into the formula for the quadratic formula. So we'll end up having that x is equal to negative b, so that'll be negative 3, which just makes positive 3, plus or minus the square root of the b term squared, that'll be negative 3 squared, so negative 3 quantity squared, minus 4 times the a term, which is 2, times the c term, which is negative 4. And then all of that will be over 2 times a, or 2 times 2 in this case. So this means that our answer will be 3 plus or minus the square root of 9 minus, now the negative times the negative here is going to make it a plus 16 times 2, or 32. And we'll divide that by 4. So from here we can just continue simplifying by saying x is equal to 3 plus or minus, now 9 plus 32 will end up giving you the square root of 41. And that will be all over 4. Now 41, we can check to see if it is divisible by any perfect squares, so we could simplify it. But I don't think 41 has anything in it that will help us reduce it. So this is actually the final answer to the problem. So let's take a look at example B, which is a little bit harder. So for example B, we first need to write it as a quadratic equation. It is not a quadratic equation at the moment. So in order to kind of simplify it a little bit, we want to get rid of the fractions. If we get rid of the fractions, it might turn into a quadratic. So we need to multiply everything by the LCD. The LCD for this example is x times x minus 5. So we'll multiply every piece by that, right? So remember the way we do this. We do 2x, put a long space, then we'll have x minus 5, then we'll have plus 1, put a space, put the value x there, and then equal to 4, and just leave room to put the LCD there. Then we multiply the LCD times everything, so it'll be times x minus 5, times x minus 5, and finally x times x minus 5. Okay, so now the fun part, the canceling part. So x minus 5's cancel out. We end up with 2x times x, which is 2x squared, plus the x here will cancel with the x there, leaving you 1 times x minus 5, or just x minus 5, right, is equal to 4x times x, which is going to give you 4x squared, and then 4x times a negative 5 is going to give you negative 20x, right, because 4 times 5 is 20. All right, from here we do have something that looks like it's quadratic in nature. Let's just move everything to one side of the equation. So in order to do that, we can basically say, well, let's bring the 4x squared over to the left. So we'll do minus 4x squared, and we'll add 20x, right, to both sides of the equation. So I'll have minus 4x squared and a plus 20x, right, to both sides of the equation. So the right-hand side of the equation will just cancel out to 0, like we want it to. But the left-hand side of the equation becomes negative 2x squared, then plus 21x, then minus 5. Now from here, we just need to identify the a, b, and c coefficients, right? So the a coefficient is negative 2, the b coefficient is 21, and the c coefficient is negative 5. All right, let's plug those into the quadratic formula then. So we'll have x is equal to negative b, so that'll be negative 21, plus or minus the square root of the b term squared, that's 21 squared, minus 4 times the a term, which is negative 2, times the c term, which is negative 5. All that will be over 2 times a, or 2 times negative 2. Okay, so just some arithmetic here to work with. So x is equal to negative 21 plus or minus the square root of 21 squared, which is 441. Then we have 3 negatives multiplied, so the answer will be negative. And then we have 4 times 2 times 5. Well, that's basically 40 because 4 times 2 is 8, and then times 5 is 40. And then all of that will be over negative 4. Okay, so we can finish this up by just saying that we have negative 21 plus or minus the square root of 441 minus 40 is 401 divided by negative 4. All right, the last little detail I'll do here is to get rid of the negative signs in the numerator and the denominator. And the way I'll do that is I'll multiply the top and bottom of this by negative 1 over negative 1. You know, that's just multiplying by 1, and you can always do that. So we'd have negative 1 over negative 1 times negative 21 plus or minus the square root of 401 all over negative 4. So the negative 1 on the bottom will, of course, produce the answer just positive 4 for the bottom of the fraction. For the top, you'll get positive 21 because a negative times a negative is positive. And then you'd have plus or minus negative 1 times the square root of 401. But it's silly to write plus and minus negative 1 because the reason why is that you'll just end up getting, in the different cases, plus and minus negative 1 again. So I'm just going to write it as, so for example, if you combine a plus minus, you end up with just a minus, right? And if you do a minus minus, you end up with a plus. So you basically end up with the same two answers either way you write it. Like I put minus plus instead of plus minus because of what the negative 1 did, but it really doesn't change the overall answer. There's basically two solutions, right? It's 21 plus the square root of 401 over 4. And of course, it's 21 minus the square root of 401 over 4. Either way, you have your two solutions to the quadratic equation.